Today, we learned about the law of sines. The cool thing about the law of sines is you could use it on a triangle even if it's not a right triangle. So, the way it works is you have a triangle where the angle A, angle B, and angle C have directly across from them sides that we label with the same letter, but lowercase. So, across from angle A, this side length is labeled little a. Across from angle B, this side is labeled little b. And across from angle C, this side's labeled little c. But the law of sines says if you take the sine of angle A divided by the length A, that should equal the sine of angle B divided by the side length B, which also should equal the sine of angle C divided by the side length C. Now, the reason why this is so useful is because now we can relate sides and angles of any triangle. I'll give you an example of one use. Here is a triangle, and it's not to scale, but that's all right. Let's say this angle is 59 degrees. This is 38 degrees. Let's say this side is 350 centimeters, and I'm trying to figure out this side. I can't use basic trigonometry because it's not a right triangle. However, I can use the law of sines. I have a problem involving two angles and two side lengths, and that's perfect for the law of sines. So, first thing I'm going to do, label my angles. I'll call this A, I'll call this B, which makes this angle C. And the side across from angle A is little a. The side across from angle B is little b. Now I can set up an equation for this. Using just the first part of the law of sines, the sine of angle A, 59 degrees, divided by the length A, which is 350, should equal the sine of angle B, which in this case is 38 degrees, divided by the length B, which is what we're trying to solve for. So if we solve this equation, we can figure out what that side length has to be. So I'm going to use cross multiplication. So I'm going to go this way and this way. So I know 350 times the sine of 38 degrees is equal to x times the sine of 59 degrees. To solve for x, I need to divide both sides by the sine of 59 degrees. And there you go. X should equal whatever this is. So really, this can all just be done on your calculator. Make sure your calculator is in degrees mode because all our angles are in degrees. But we could just type this all in straight into our calculator and find out what it is. I'm putting 350 times sine of 38 degrees in parentheses divided by the sine of 59 degrees. It's approximately, and we're going to go to the hundredth, 251.39, in this case, centimeters. And that's the length of the side. So that is my unknown side length. So anytime you're dealing with two angles and two sides, you can use the law of sines. I'm going to show you one more example. This time, the example is going to be missing an angle, and you'll see it's a slightly different problem, but not that much different. Again, this picture is probably not to scale. Here's 68 degrees. Here's the angle I don't know. This side's 150 centimeters. This side is 250 centimeters. All right? So, first thing I'm going to do, label everything. I'll call my angles A and B, which makes this one C. The side across from angle A is A. The side across from angle B is going to be labeled little b. Now I can set up my equation. The sine of 68 degrees, the sine of A, which is 68 degrees, divided by the length of A, which is 250, should equal the sine of angle B, which is x, over the length of B, which is 150. So notice, this time, I don't know the angle, so I'm going to have to use the inverse of sine to solve for x. But first, I'm going to multiply both sides by 150. So I end up getting 150 times all that stuff, which is a lot of stuff, but fortunately we had the calculator to do all that work, equals, because these cancel out, the sine of x. And to get x, I'm going to have to use the inverse of sine. So basically, I'm taking the inverse of sine of all of that. So you're going to have to be very careful when you enter all this in your calculator, because it's a lot. But fortunately, our calculator can do all this for us. So let's see what we've got. We want the inverse of sine. Let's see if I can do it. Inverse of sine of 150 times the sine of 68 degrees divided by 250. There it is. So my angle should be approximately 33.80 degrees. All right, so this is the law of sines. Anytime you have a triangle that's not a right triangle, and you're given, or you're dealing with, two angles and two side lengths, you can use the law of sines to set up an equation and then find either an unknown side or an unknown angle.